The Earth is not standing still beneath you. Even now, as your body settles, you are falling, quietly, continuously, through the depths of space. You drift around the sun at nearly 30 kilometers per second. You spiral with the solar system through the Milky Way. And the galaxy itself moves through the cosmos in a vast, silent glide. Yet through all of this motion, you feel nothing at all. No pull, no sway, no whisper of the journeys your atoms are taking. It is one of the most gentle illusions in physics, the feeling of stillness in a universe that never rests. If this quiet journey brings you even a moment of peace, I'm deeply grateful you're here. A gentle like or a soft tap on subscribe helps keep these night voyages alive, and your presence means more than you know. Now, we drift into the first truth. Part 1. Why you never feel the Earth falling through space. Even as you sit perfectly still, you are moving with the Earth in perfect unison. Your body, the air around you, every atom in your bones shares the exact same motion. There is no jolt, no shift, no difference for your senses to detect. In physics, motion is only felt when it changes, and Earth's motion is as steady as a heartbeat written into the fabric of the cosmos. To understand why you feel so still, we begin with one of the quietest truths in all of physics. Motion, by itself, is invisible. You only sense it when something interrupts its smoothness, when a car accelerates, when a train brakes, when an airplane lifts from the runway. Your inner ear is exquisitely sensitive to changes in speed, but utterly indifferent to speed that remains constant. That simple rule, so small in scale, becomes profound when applied to the planet beneath you. Because Earth's motion, the rotation, the orbit, the drift through the galaxy, is nearly perfectly uniform. It does not jerk, it does not surge, it does not shudder. And so, your senses have nothing to notice. The ground beneath your feet is turning eastward at more than 1,000 miles per hour. In the same moment, you are carried around the sun along a 940 million kilometer loop, traveling nearly 30 kilometers each second. And beyond that, the entire solar system is gliding around the Milky Way, sweeping through its spiral arms in a quiet orbit that lasts 230 million years. Yet, in the midst of all this motion, spinning, circling, drifting, you feel anchored, grounded, untouched. The stillness is not a contradiction. It is the definition of what physicists call inertial motion, smooth, uninterrupted movement that produces no sensation at all. You experience something similar every time you ride an airplane. At cruising altitude, the aircraft moves at hundreds of miles per hour, yet the tea in your cup remains calm, your breath steady. Only when the plane rises or dips do you feel the motion. The Earth is traveling far faster, through far larger distances, yet it travels with the same serene steadiness. That steadiness shields your senses, allowing the most immense motions of your existence to pass as silence. There is another reason you feel so still. You are not just moving with the Earth. You are part of its motion. Every molecule in the air, every drop of water in the oceans, every fragment of crust and cloud and city, everything is rotating and orbiting together. There is no difference for your body to detect, no shifting wind of space to brush past your skin. In the vacuum beyond the atmosphere, there is nothing to create drag, nothing to press against you as the Earth hurls through space. Motion without resistance feels exactly like rest. If there were air outside, if stars were embedded in a fluid that brushed past the planet, you would feel a cosmic wind at thousands of miles per hour. But space is silent, empty, too empty to reveal how fast you're moving. Isaac Newton understood this beautifully. He showed that an object in motion stays in motion unless acted on by an external force. Earth faces almost no such forces in the vacuum of space. Its rotation and orbit continue with extraordinary regularity. Without friction to slow it, the planet becomes an enormous cosmic version of a smoothly gliding train, one whose passengers feel none of the speed because everything moves together. The stillness you perceive is the harmony of shared motion. Astronauts experience the same illusion on a more dramatic scale. When they orbit Earth aboard the International Space Station, they travel at 7.66 kilometers per second, fast enough to circle the planet every 90 minutes. Yet, inside the spacecraft, everything feels weightless and calm. There is no rumble, no sway, no sensation of cutting through the air. Without friction, without turbulence, motion becomes pure. The astronauts float not because they are far from gravity, but because they are falling endlessly around Earth. Their fall perfectly matches their forward motion, so they never hit the ground. You too are falling with the Earth, held to its surface by gravity as the entire planet falls around the Sun. This idea, that orbit is just falling with style, reveals another layer of stillness. Falling is a form of motion defined not by speed, but by acceleration. If you drop a stone, it accelerates toward the ground. If you fall from a great height, you feel your stomach rise because your body senses the acceleration. But an object in orbit isn't accelerating downward in the way a falling stone does. It is continuously missing the ground as it falls, tracing a curve so perfectly balanced that the sensation of falling disappears. Every orbit is a kind of equilibrium, a compromise between gravity and forward motion. And stable equilibrium is always experienced as calm. Your senses evolved for a world of forests and rivers, not the sweeping trajectories of celestial mechanics. The inner ear measures changes in motion at human scales, walking, running, turning, not the enormous uniform motions of a Shei rotating globe. Even if Earth rotated 10 times faster, you still wouldn't feel the spin. The only detectable clue would be stronger winds at the equator and more dramatic weather patterns. But the motion itself, the rotation beneath your feet, would remain unfelt, hidden behind the symmetry of inertia. There are tools, though, that can reveal the truth. A simple pendulum swinging freely will gradually twist relative to the floor beneath it, a gentle, silent demonstration that the Earth is turning. This is the principle behind the Foucault pendulum. You may have seen one in a museum, its long wire suspending a weight that swings with perfect patience. Over hours, the pendulum appears to rotate, but in reality, it is the Earth beneath it that slowly moves. The demonstration is so simple, so quiet, that it feels like watching time made visible. On a vaster scale, astronomers observe the motion of stars across the sky. Over weeks, the constellations drift by tiny amounts. Over months, they shift positions as the Earth moves along its orbit. Over millennia, the axis of the planet slowly wobbles, tracing a slow, patient circle across the heavens. These motions unfold too slowly to feel, too smoothly to experience, but they leave signatures in the night sky that reveal the Earth's true journey through space. And deep beneath that cosmic choreography lies a principle that keeps everything in balance: conservation of angular momentum. When Earth formed from a swirling cloud of gas and dust, it inherited the spin of the collapsing material. That primordial spin is still with us, unchanged through billions of years, except for the tiny slowing effect of the moon's tides. Every rotation of the planet, every orbit around the sun, every drift through the galaxy is a continuation of that ancient motion, motion so stable that it becomes indistinguishable from rest. This is why you never feel the Earth falling through space, not because you are still, but because you are carried by motion so old, so smooth, and so universal that it erases all sense of movement. You are part of a system that has been gliding for billions of years, a system whose stability makes life possible. And as we drift deeper into this journey, one question naturally follows. If Earth is falling around the sun without pause, then what unseen forces keep the entire solar system moving in such perfect harmony? Part 2. The invisible speed. Beneath your quiet life. You're carried eastward at thousands of kilometers per hour, swept around the sun at tens of thousands more, and pulled by the galaxy at nearly 500,000 miles per hour. Yet, all of this motion layers together so smoothly that it disappears into silence. The universe moves too gracefully for you to notice, and that grace is what makes life feel still. The speeds that shape your life are enormous, so enormous they're difficult to hold in your imagination. The Earth's rotation alone carries you around the planet, faster than the speed of sound. At the equator, you move with a velocity of about 1,270 kilometers per hour, yet there is no rush of wind, no pressure on your skin, no tremble beneath your feet. Because you are not being pushed, you are simply carried. Every grain of soil, every breath of air, every building and ocean and mountain shares that same rotational speed. There is no difference for your senses to detect, no tug that marks where motion begins and ends. Everything around you moves in unbroken harmony. Beyond this spin, Earth pulls you into an even greater journey, its orbit around the Sun. In a single second, you travel nearly 30 kilometers along a vast elliptical path. In 1 hour, you cover more distance than most people will travel in a lifetime. Yet again, you feel nothing. The orbit is smooth, ancient, and precisely balanced. The ground does not jolt. The sky does not sway. The seasons change quietly, following rhythms too slow for the body to sense. But Earth's orbit is only the second layer of your cosmic motion. The entire solar system participates in a grander drift, orbiting the center of the Milky Way. Our star, the Sun, is pulled by the galaxy's combined mass. Hundreds of billions of stars, swirling dust lanes, dark matter halos, moving at nearly 490,000 miles per hour, or about 220 kilometers per second. It is a speed beyond anything we've ever built, beyond anything we've felt, beyond anything our senses were designed to comprehend. Yet it passes through your life as gently as a breeze that never touches your face. Why is something so magnificent so quiet? The answer lies in how perfectly these motions align. Each layer, rotation, orbit, galactic drift, moves you in one continuous stream. None of these motions whip you back and forth. None slam you forward or drag you behind. The universe does not lurch, it glides, and any motion that glides leaves the body in peace. The structure of this grand movement follows the laws of gravity, and gravity is the ultimate artist of smoothness. It never jolts, it never snaps, it curves space gently, drawing Earth into orbit, guiding the movement of the Sun, shaping the spiral of the galaxy. Gravity's touch is so steady that even its immense force becomes a kind of silence. It is not felt through wind or friction or pressure. It is felt only as weight, the weight that anchors you to the ground as the Earth carries you across cosmic distances. Imagine if these motions were not smooth. Imagine if the Earth's orbit shifted abruptly, or if the Sun jerked suddenly within the galaxy. The oceans would surge sideways across continents. The air would roar at thousands of miles per hour. Trees would bend, mountains would tremble, and life would be swept away. But nature avoids chaos. Gravity prevents it, binding every motion into long, stable curves. These curves protect you. They shield you. They allow you to move through the universe without ever knowing it. There's a principle in physics that helps explain this: inertia. It is the quiet tendency of every object to keep moving exactly as it is unless something forces a change. The Earth spins, it keeps spinning. The Earth orbits, it keeps orbiting. The solar system drifts, it keeps drifting. There is nothing to slow these motions, no external force strong enough to stop them. Space is an almost perfect vacuum, and in that vacuum, motion becomes eternal. Because you share these motions with the Earth, inertia makes them feel non-existent. Your body is not fighting against these speeds, it is part of them. The air in your lungs moves with you, your heartbeat moves with you. Even the particles inside your atoms ride along with the planet, tracing the same invisible arcs through space. You are not a passenger separate from the Earth, you are stitched into its motion. Astronauts aboard the International Space Station describe a similar sensation. Traveling at 28,000 kilometers per hour, they orbit Earth once every 90 minutes. Yet inside the station, everything floats gently. Pens drift, water forms spheres, people move in slow glides. The station's tremendous speed is erased by its perfect smoothness. Only when the engines fire, a brief, gentle push, do astronauts feel any shift at all. That slight sensation is what your body never feels from the Earth, because the planet's movement has no equivalent engine burn. It is pure, uninterrupted motion. Even on our cosmic journey through the galaxy, this same principle holds. The Milky Way's rotation is vast, Spanning 100,000 light years, its spiral arms flow like slow rivers of stars. Dark matter envelopes it, shaping its motion like a quiet, invisible current. Our solar system drifts within this river, carried by gravity so steadily that no part of the system feels strain or pressure. Speed, at these scales, becomes indistinguishable from stillness. But your velocities do not end with the galaxy itself. The Milky Way is moving too, pulled toward the Virgo cluster, drifting through the cosmic web, influenced by the gravity of superclusters beyond human imagination. Even on these gargantuan scales, motion remains smooth, and that smoothness remains silent. When scientists measure these movements, they use light from distant galaxies. The light stretches or compresses depending on how we move relative to its source. Redshift, blue shift. These subtle changes reveal speeds that would feel impossible if our senses could perceive them. But they cannot. Our biology is bound to Earth's surface. It evolved to understand height and balance, not the drift of galaxy clusters. And so the universe hides its motion in plain sight. Yet, the evidence is everywhere if you know how to look. Pendulums reveal Earth's spin. The seasons reveal its orbit. Star maps reveal the motion of the sun through the galaxy. Cosmic background radiation reveals the motion of the galaxy through the universe. These clues, layered across centuries of observation, confirm the truth that your senses cannot. Your quiet life is lived within a storm of motion so smooth you never feel a whisper of it. And this raises a deeper question, one that carries us forward into the next chapter. If the universe is moving with such silent precision, then what force carries the solar system and our entire galaxy through the cosmic ocean? Part 3. How inertia protects your sense of stillness. Inertia is the quiet guardian of your calm. It keeps your body moving with Earth's rotation and orbit without the slightest friction or disruption. Because you share the planet's smooth, ancient motion, you feel no wind of the cosmos brushing past, no tug of acceleration. Instead, you drift through space in perfect balance with the world beneath you. To understand why inertia shields you so completely, begin with a simple truth. Motion does not require effort. It does not need pushing, pulling, or powering. An object already in motion, whether a stone, a planet, or your own body, continues moving unless something disturbs it. This rule, described by Isaac Newton centuries ago, is deceptively gentle. It means the universe prefers smoothness. It prefers silence. It allows anything already gliding through space to keep gliding indefinitely. You feel motion only when something changes. When a car accelerates, your body leans back. When it brakes, you tilt forward. When a train turns, you sway toward the outside of the curve. Your inner ear, filled with tiny canals of fluid, detects every shift and every jolt. But when a car cruises at a steady speed, you feel as if you're sitting still. Inertia has taken over. The motion becomes invisible. Now, imagine this principle not inside a car or train, but at the scale of a planet. Earth is spinning at more than 1,000 miles per hour, orbiting the sun at nearly 67,000, and drifting with the solar system through the Milky Way at almost 500,000 miles per hour. And yet, you are unaware of any of it. That silence is not an accident. It is the consequence of perfect uniformity. The Earth does not start or stop. It does not jerk or lurch. It moves with the calmest, most consistent grace, and because your body shares that motion exactly, you feel nothing at all. Inertia, at its heart, is a promise the universe makes. If nothing interrupts you, you will never even know you are moving. This shared motion is why you don't feel an interstellar wind, why there's no roar of the galaxy brushing past your skin. The Earth carries you as if you were part of its surface, not a passenger. The air moves with the Earth. The oceans move with it. Every molecule of your body drifts with the same ancient trajectory. There is no difference for your senses to detect. Even the stars reflect this principle. If you look up at the night sky, the constellations appear fixed. They rise and set predictably, tracing the same arcs they have traced for thousands of years. But the Earth is spinning beneath them. You are rotating with the planet, turning silently into the night and into the dawn. Yet the sky seems still because you turn with it, not against it. Smooth motion erases the sense of movement. Inertia also explains why astronauts aboard the International Space Station float in calm weightlessness. They travel around Earth at 17,500 miles per hour, fast enough to orbit the planet once every 90 minutes. Yet, inside the station, they drift gently, as if hovering in place. The station is in free fall, continuously falling toward Earth, but moving so fast forward that it never hits the ground. This falling is so perfect, so unbroken, that it feels like stillness. Inertia carries astronauts through their orbit, the same way it carries you across the planet's surface, quietly, evenly, without interruption. But the most profound aspect of inertia is not merely that it hides motion. It hides motion across every scale. Every level of the cosmos obeys this rule. Galaxies rotate for billions of years without slowing down. Stars orbit galactic centers with a grace that would be impossible if space were filled with friction. Even the tiny particles inside atoms move in constant, restless patterns, held in motion by forces rather than by effort. This cosmic smoothness means that stillness is not something you experience because you are unmoving. It is something you experience because you are moving perfectly. Consider a drop of water resting in your hand. It seems still, but it is being carried by the Earth's rotation, Earth's orbit, the solar system's drift, the galaxy's rotation, and the expansion of the universe itself. Nothing about that water is truly stationary, but every layer of that motion is shared. The water experiences no difference between itself and the world around it, so it stays perfectly calm. The same is true for you. Your senses evolved to detect changes in motion, those rare moments when inertia is broken. On Earth, these changes are tiny. A gust of wind, the shift of an elevator, the sudden stop of a moving car. But at cosmic scales, the universe is far too smooth to interrupt you. There is no galactic bump in the road, no sudden shift in orbit that would jolt your body awake. The vacuum of space is too empty, too frictionless, too serene to disturb the Earth's path. If the Earth were to suddenly accelerate or decelerate, even by a fraction of a percent, the effect would be catastrophic. Everything not anchored to the ground would be hurled sideways. The oceans would surge across continents. The atmosphere itself would tear and roar. The planet's surface would be reshaped in moments, but such events never happen. Gravity binds us into gentle curves. Inertia stabilizes our paths. The solar system glides in a smooth orbit that has lasted for billions of years and will continue for billions more. This reliability is what makes life possible. Inertia gives the Earth its consistent day-night cycle. It allows the seasons to unfold in predictable patterns. It ensures that energy from the sun arrives steadily, not in bursts. Without inertia, the world would be chaotic, unpredictable, hostile. But because of inertia, you wake each morning to a sky that brightens gradually. You watch shadows shift patiently across the ground. You see stars emerge in slow procession at night. These rhythms are not accidents. They are the natural consequence of motion so smooth that it feels like stillness. And this stillness is not just physical. It shapes your perception of time itself. Because motion is constant and unbroken, your experience of time is also steady. Seconds tick by at the same rhythm. Hours unfold with the same quiet predictability. If motion were erratic, the flow of time would feel unstable. But our planet's inertia gives us a sense of continuity, of groundedness, of calm. Even language reflects this idea. We say the Earth turns, as if the motion were active and deliberate, but in truth, the Earth is simply continuing its ancient spin, a leftover momentum from when our solar system formed from a collapsing cloud of gas and dust. That original, swirling motion, born more than 4.5 billion years ago, still carries us today. We are passengers of momentum older than life itself. So when you lie down at night and feel completely still, remember that stillness is not the absence of motion. It is the perfection of motion. It is inertia wrapping you in a blanket of calm, allowing the Earth's great journeys to slip past unnoticed. And as we drift deeper, a new question arises. If inertia keeps Earth's motion invisible, then what forces shape that motion in the first place? And how do they guide the solar system's path through the galaxy? Part 4. Why falling in space doesn't feel like falling to fall is to follow gravity's curve, and every object in orbit is doing exactly that. Satellites, the moon, even you, everything is in continuous free fall. But because that fall is perfectly matched by forward motion, the sensation vanishes. What remains is not a drop, but a glide, a quiet bending of your path through space-time. Falling is one of the first sensations your body ever learned. As an infant, the smallest dip in motion sends tiny alarms through your nerves. Even as an adult, your stomach lifts when an elevator begins its descent, and a roller coaster's drop can make your heart skip. Falling feels dramatic because on Earth, falling and accelerating always happen together. Gravity pulls you downward with a force your body immediately feels. You accelerate. The air presses against your skin. Your inner ear floods with signals that something has changed. But orbit is not falling as you know it. It is falling transformed, falling without ever getting closer, falling sideways with just the right speed to keep missing the ground. It is a balance so perfect that gravity becomes invisible. And when gravity becomes invisible, falling becomes stillness. Imagine launching a ball from a mountaintop. If you throw it gently, it arcs and drops to the ground. Throw it harder and it travels farther before landing. Throw it fast enough, about 28,000 kilometers per hour, and something extraordinary happens. The curve of its fall matches the curve of the Earth. The ball falls, but the ground curves away beneath it at the exact same rate. It is forever falling and forever missing. That is orbit. That is what satellites, the moon, and the International Space Station experience. And that is what you experience too, though from the comfort of Earth's surface, held in place by the planet's gravity while the whole world falls around the sun. Free fall feels weightless because weight is not gravity itself. Weight is the force you feel when something stops you from falling. Stand on the ground, and the Earth pushes back against your weight, supporting you. Sit in a chair, and the chair pushes upward. These forces give weight its familiar sensation. But in orbit, whether aboard the space station or in a spacecraft diving around the moon, nothing stops you from falling. There is no opposing force. You drift, unanchored, experiencing the pure effect of gravity without resistance. That purity feels like floating. Astronauts describe this sensation with wonder. They say their bodies feel released, as if a constant pressure they never noticed has suddenly disappeared. Objects do not fall downward. They drift wherever they are nudged. A drop of water becomes a glistening sphere. Tools float beside their hands. Even sound behaves differently, traveling only through the air pumped into the station, not across the silent vacuum outside. Everything becomes gentle, every movement slow, effortless, cloud-like. This weightlessness is not the absence of gravity. It is gravity in its most natural state. The moon, orbiting Earth, is not suspended in place. It is falling around the Earth with the same kind of continuous sideways descent. It has been falling for 4.5 billion years and will continue falling for billions more. The reason it never crashes into our planet is because its forward motion keeps it at just the right distance, a balance refined by time and tidal forces. Even Earth circling the Sun is doing the same. Our planet falls toward the Sun at every moment, pulled inward by gravity. But its orbital speed, nearly 30 kilometers per second, ensures that the fall forever curves around the Sun, not into it. You feel none of this because everything around you is falling exactly as you are. There is no difference in motion to detect, no uneven pull to register, no sudden acceleration to trigger your senses. Albert Einstein understood this deeply. He realized that free fall is special, not because it reduces gravity, but because it erases the sensation of gravity entirely. His famous equivalence principle states that being in free fall is indistinguishable from floating in space far from any gravitational influence. If an elevator cable snapped and you fell inside it, you and the elevator would accelerate together. A pencil drifting beside you would float. For that brief moment of descent, gravity would vanish from your experience. You would be weightless even as gravity pulled you downward. This idea becomes even more profound when viewed through Einstein's theory of general relativity. In that framework, gravity is not a traditional force, it is the curvature of space-time itself. Objects follow the straightest possible paths through that curved space-time, and those paths are what we perceive as falling. To fall is simply to follow space-time's natural geometry. To orbit is to follow that geometry so perfectly that your path closes on itself, forming a loop around the object that curves space. Seen this way, orbit is not a fight against gravity. It is gravity's purest expression. And the reason you feel none of this, neither Earth's fall around the sun nor your own descent through space-time, is because your body is following the same curve as everything around you. No part of your body falls faster or slower. No structure around you falls differently. There is no internal shearing, no tug of war, no imbalance. In physics, only differences in acceleration create sensation. And in the Earth-Moon-Sun system, those differences are incredibly small. Even tides caused by the moon's pull are too gentle to feel in your body. They stretch oceans by meters, but they stretch your body by less than a trillionth of a meter, far too small for nerves to detect. The smoothness of this falling, the uniformity of it, renders it invisible to every sense you possess. If falling in orbit feels like floating, then why does falling on Earth feel so dramatic? Because on Earth's surface, your fall is interrupted. Air resistance pushes against you. The ground halts your descent abruptly. Your body senses the change, not the motion. That change is what creates weight, pressure, impact. Without it, falling becomes a glide. One of the most haunting demonstrations of this comes from astronauts during spacewalks. As they drift outside the space station, the Earth rotates beneath them in slow, magnificent silence. They describe a sensation not of falling toward the planet, but of drifting above it, because their fall matches the station's fall, and the station's fall matches Earth's orbit. Everything is aligned, everything moving together, everything balanced. Weightlessness becomes a state of harmony, not danger. This harmony exists even at cosmic scales. Stars fall around the centers of galaxies. Galaxies fall within clusters. Clusters fall toward denser regions of the universe. Everything that moves follows space-time's curves, and every curve is a kind of fall. Yet the universe is overwhelmingly calm, because these falls are not chaotic plunges. They are long, patient, circular dances shaped by gravity over billions of years. In fact, if the universe ever stopped falling, if gravity vanished, everything would fly apart into straight lines, never meeting, never forming stars or planets or worlds like ours. Falling is not only safe, it is necessary. It is the mechanism that gathers matter, sculpts galaxies, and allows planets to cradle life. Without the quiet curvature of space-time, there would be no orbits, no seasons, no sunrise, no tides, no stability. So the next time you look up at the moon, remember, it is falling. Every moment, elegantly, endlessly, and you are falling too, not downward, but around. What feels like stillness is motion in its most refined form. And as we continue this quiet journey, another question begins to rise. If everything is falling through space-time, then what exactly is space-time, and how does it shape the world we experience? Part 5. How Einstein redefined motion and stillness. Einstein showed that motion is never absolute. It exists only in comparison. From your point of view, the Earth feels still, and the universe appears to move around you. From another frame, you are the one crossing unimaginable distances. This symmetry, simple, profound, is why stillness is so often a matter of perspective. To understand how deeply this idea reshaped physics, imagine standing in a quiet field at night. The air is still, the ground is still. Your breath settles softly against the cool dark. Above you, the stars wheel slowly across the sky in a pattern older than civilization. It is easy, almost natural, to believe that you are the center of this rotation, that everything is turning around you. This illusion has lived in human consciousness for tens of thousands of years. For most of our history, we believed the Earth stood still while the heavens moved. Einstein revealed something gentler, yet far more startling. Stillness is not a universal truth, it is a viewpoint. In the early 20th century, physicists faced a puzzle. The laws of motion worked beautifully in some situations, but broke down when dealing with light and high speeds. They assumed motion must be measured against some hidden backdrop, a fixed stage on which the universe performed. But every attempt to detect such a stage failed. The speed of light stayed constant regardless of how one moved, denying the idea that there was anything absolute to measure motion against. Einstein took a quiet, radical leap. He proposed that there is no cosmic stage, no universal frame, no single perspective privileged above others. Instead, every observer, whether drifting in a spacecraft, sitting on a hillside, or orbiting a distant star, carries their own sense of rest with them. Your stillness is not the universe's stillness. It is simply the motion you share with your immediate surroundings. If you're on Earth, you move with Earth. If you're on a ship, you move with the ship. If you're in a galaxy, you move with that galaxy. From your own frame of reference, you are always still. This idea, that motion is relative, became the cornerstone of Einstein's special theory of relativity. It fixed one rule. The laws of physics must be the same for every observer moving at constant speed. No exceptions. And to preserve this equality, something astonishing had to happen. Space and time themselves had to flex. Distances could shrink. Time could slow. Events that seemed simultaneous to one observer might unfold in different order for another. In Einstein's universe, motion reshapes the very structure of reality. And yet, these distortions are not violent or chaotic. They are subtle, gentle, and beautifully consistent. They reveal that stillness is never a fact, only a feeling. Consider a passenger on a train gliding at constant speed. Inside the train, the passenger pours tea, reads a book, hears the quiet hum of the carriage. To them, everything seems perfectly still. To someone standing by the tracks, the train is a streak of motion. But neither viewpoint is wrong. Both are valid descriptions of the same event. Einstein elevated this simple everyday truth into a universal principle. Apply that principle to the Earth, and the world transforms. You feel still because the planet is your train, your moving frame. You are carried with it so perfectly that motion and stillness become indistinguishable. But if motion is relative, what is rest? Einstein's answer was quiet and profound. Rest is simply the state in which you feel no push or pull, no acceleration. The Earth, moving smoothly through space, provides exactly that. You feel the floor under your feet pushing up against gravity, but you feel no sideways tug, no cosmic wind. You can sit, breathe, sleep, and dream without sensing a hint of the planet's unimaginable speed. Yet from the sun's point of view, you are orbiting at nearly 30 kilometers per second. From the galaxy's point of view, you are drifting on a spiral arm through a turning sea of stars. From the universe's point of view, you are part of a vast migration shaped by gravity over billions of years. Your calm is built from motion, woven so perfectly into your experience that it becomes invisible. Einstein helped us see that stillness is not a physical state, it is a local one. Even time flows differently depending on your motion. Atomic clocks moving quickly tick more slowly than identical ones on Earth. This is not a theoretical idea. It is measured daily in satellite systems like GPS, where engineers must adjust for relativity to keep time accurate. Without those corrections, your phone's navigation would drift by kilometers each day. This means that time, something you assume universal and steady, is shaped by motion just as surely as a river is shaped by the land it flows across. The more precisely scientists measured the universe, the more Einstein's insight became unavoidable. Every observer experiences their own version of reality, built from their own motion through space and time. Your sense of stillness, then, is not naive. It is natural. The universe does not offer a single objective viewpoint from which motion can be measured. It offers countless viewpoints, each one true in its own frame. Your personal experience of calm is as real as the galaxy's perspective of your motion. This idea becomes even more astonishing in the realm of general relativity, Einstein's extension of his theory to include gravity. Here, motion and stillness become intertwined with the curvature of spacetime. Gravity no longer acts like a force pulling objects toward each other. Instead, it is the bending of space-time itself. You follow that curve naturally, just as a leaf follows the current of a river. In this view, a planet orbiting a star is not being dragged or pushed. It is simply moving along the straightest possible path in a curved landscape. You do not feel the curve, just as a hiker walking across a gentle hill may not notice the slope beneath their feet. Your stillness on Earth is this subtle. You sit on a planet whose space-time is curved by the sun, which is in turn curved by the Milky Way, which is curved by the invisible presence of dark matter. And yet you feel none of it. Gravity provides the structure, inertia provides the ride. Together they create a world where you can drift through the universe without a sense of motion. Even the Earth spinning does not contradict your stillness. The air spins with the planet, the oceans spin with it. Every tree, mountain, and heartbeat is part of the same rotation. From your frame, nothing changes. The speed is constant, the direction unbroken. Without acceleration, rotation becomes a hidden rhythm, not a felt force. Only at the equator, where water bulges outward slightly, does Earth's spin leave a subtle imprint. But even there, the sensation is lost beneath the much greater sensation of gravity pulling you downward. Einstein's revolution was not simply scientific, it was philosophical. It dissolved the idea that there is one correct vantage point from which to understand the universe. Instead, it revealed a cosmos where every point of view is a story, and every story is true within its own domain. You could be standing perfectly still on your porch, watching the stars drift overhead, or you could be hurtling through space at enormous speeds. Both descriptions are accurate, both coexist, both shape reality. Stillness becomes something deeper, a personal reading of motion, shaped not by the universe at large, but by the frame in which you live your life. So the next time you feel the quiet of night settling around you, remember that the calm you sense is not the absence of motion, it is the perfection of motion. It is the universe honoring your frame of reference, offering you a place of peace within its vast, restless architecture. And as we step into the next chapter, another question begins to take form. If motion depends on perspective, then what determines the frame we use to understand the Earth's journey through the cosmos? And how does that frame shape what we believe about our place in the universe? Part 6. The quiet geometry of Earth's orbit. Earth's path around the sun is not a perfect circle. It is a gentle ellipse, a stretched loop of motion shaped by gravity and time. As the planet glides along this curve, its speed subtly changes, yet you never notice. Those variations are absorbed into the rhythm of the year, hidden beneath the fabric of your ordinary days. To understand this quiet geometry, imagine drawing a circle in the sand with a stick. The distance from the center remains constant as you rotate your hand. But an ellipse is different. It has two foci, two invisible anchors that guide the curve. For Earth, one of those foci is occupied by the sun, while the other rests silently in empty space. This simple displacement, this slight off-center position, is what shapes nearly everything about our journey around the sun. It creates seasons, influences climate, dictates the length of days, and determines how much warmth spills across the surface of our world. Yet the Earth's orbit is so gentle, so smooth, that all of it happens without disturbing your life. If the orbit were a perfect circle, our distance from the sun would never change. But the ellipse, though subtle, means we drift closer during part of the year and farther away during others. At our closest point, perihelion, Earth comes within about 147 million kilometers of the sun. At its farthest, aphelion, the distance stretches to around 152 million kilometers. You travel millions of kilometers closer and then farther every year, and you never feel a moment of that journey. Your senses are simply not designed for cosmic scales. They evolved to feel the difference between firm ground and uneven soil, between warm air and cool breeze. Not the difference between the Earth being 1% closer or farther from the sun. Even Earth's orbital speed changes across this ellipse. When we are nearer the sun, gravity pulls more strongly, and the planet moves faster. When we are farther away, gravity's tug is weaker, and our pace slows. But the change is subtle, unfolding over months, felt only by precise instruments, not by bodies shaped for a small world. As Earth glides along this elliptical path, everything on its surface participates in the same motion. The oceans ripple with tides shaped by the moon's pull. Continents drift slowly due to plate tectonics, while weather systems swirl across the atmosphere. Yet beneath all of this earthly activity lies the deeper, quieter trajectory of our orbit, a movement so stable that life has adapted to its rhythmic predictability. This predictability comes from a simple but powerful law: Kepler's laws of planetary motion. Johannes Kepler, studying the meticulous observations of Tycho Brahe in the 1600s, discovered that planets do not move in perfect circles, but in ellipses. Also found that planets sweep out equal areas in equal times. This means Earth moves faster when closer to the Sun and slower when farther away, but these changes occur in such a balanced way that each segment of the orbit covers the same area over the same span of time. Kepler glimpsed the geometry of the cosmos long before we understood gravity's true nature. He sensed that the universe was not chaotic, but ordered, its complexity built from gentle curves, not jagged edges. Later, Isaac Newton provided the key to these motions. Gravity, he realized, is what keeps planets in orbit, not a push, not a guiding hand, but a mutual attraction. The Sun pulls Earth inward, and Earth's motion carries it sideways. The result is a balanced fall, a falling around instead of falling into. This balance produces the ellipse, just as a stone on a string traces a circle when spun, but drops into a curve if the spin weakens. Einstein deepened this understanding. In his view, gravity is not a force at all, but the curvature of space-time. The Sun bends space-time around it, and Earth simply follows the straightest possible path through that curved landscape. The ellipse is the natural result of moving through warped geometry. You feel no pull toward the Sun because the orbit is not a tug of war. It is a glide through a gently curved valley of space-time. This valley is so shallow and so smooth that the planet's motion becomes indistinguishable from stillness. Even though Earth's orbit shifts subtly each year, these shifts accumulate into larger cycles spanning tens of thousands of years. Known as Milankovitch cycles, they include changes in eccentricity, the shape of the orbit, axial tilt, and the wobble of Earth's rotation. These slow dances influence ice ages, patterns of sunlight, and long-term climate rhythms. Yet these cycles unfold over scales far beyond human lifetimes. You do not feel them. You live inside them. They form the background, the quiet architecture of seasons, without ever whispering their secrets to your senses. Your experience of the year, spring warming into summer, autumn softening into winter, is not shaped primarily by distance from the Sun, but by the tilt of Earth's axis. This tilt ensures that sunlight falls unevenly across the hemispheres. Yet the elliptical orbit modulates these seasons, adding subtle variations to temperature, length of day, and weather patterns. At perihelion, Earth receives slightly more solar energy. At aphelion, slightly less. These differences are small, but they influence monsoons, storm tracks, and the flourishing or fading of certain climates. The elliptical orbit also shapes the length of seasons. Because Earth moves faster when closer to the Sun, the northern hemisphere's winter and the southern hemisphere's summer are slightly shorter. Conversely, when Earth is farther away and moving more slowly, northern hemisphere summers last a little longer. These quiet asymmetries ripple across biology. They guide the migrations of birds, the cycles of plants, the patterns of ocean currents. Yet they do so invisibly, woven into the background rhythm of the world. To your senses, the year is simply a flow of days, summer sunsets, autumn winds, the long calm of winter nights. But underneath that familiar sequence lies the patient geometry of the ellipse. The planet glides faster here, slower there. The Sun stands off-center. Gravity sculpts the path like an artist smoothing clay into a curve. And your life is shaped by this curve, molded by it, calibrated to it. This calibration is ancient. Long before civilization, early humans noticed the Sun's path across the sky shifting. They built structures aligned with solstices and equinoxes. They watched shadows change. They traced the arc of sunlight across valleys and plains. Even without mathematics, they sensed that the sun's rhythm was not perfectly uniform. They lived with the quiet geometry long before they could name it. Today, spacecraft, telescopes, and precise instruments can measure the orbit to extraordinary accuracy. We know the eccentricity, the distances, the speed changes. Yet, none of this precision makes the orbit feel more tangible. You still experience it as stillness. The Earth's long elliptical fall is too smooth, too constant, too evenly shared to ever stir your senses. You do not feel the subtle acceleration at perihelion. You do not feel the gentle easing as Earth drifts toward aphelion. The planet moves through these changes with such composure that even the sky seems unaware of the variations. Sunlight arrives each morning with quiet consistency. And this quiet geometry extends far beyond Earth. Every planet in the solar system follows its own ellipse, each one shaped by gravity, motion, and time. Mercury's orbit is the most stretched, Venus is almost circular, Mars is delicately elongated. Each world sweeps through its curve, held steady by the sun's presence. Their motions compose a cosmic dance, complex in detail, but harmonious in its overall rhythm. You live inside this harmony. Your days and nights are woven from its geometry. Your seasons echo its shape. Your climate responds to its gentle shifts. Everything you see and touch on Earth is part of this motion, part of this orbit, part of this quiet circle that isn't truly a circle. And so, when you look up at the sky and see the sun rising each morning in its familiar glow, remember that rising is the result of a planet gliding along a gentle ellipse, carried by gravity, guided by space-time, moving too gracefully for your body to ever feel. As we continue deeper into this journey, another question unfolds softly. If Earth's orbit is only one quiet curve among many, then how does the geometry of the entire solar system weave together into the stable structure that cradles our world? Part 7. Why space feels like silence. Space is nearly empty, so empty that there is nothing to brush against your skin, nothing to create the drag or turbulence that would reveal your speed. Without air, without resistance, motion becomes pure, smooth, perfect, and in that perfection, it becomes invisible. The silence of space is not just the absence of sound, it is the absence of interruption. On Earth, your senses are constantly informed by the world around you. Air presses against your body, wind tugs at your clothes, every step generates friction, every movement creates a ripple through the medium of the atmosphere. These gentle pressures, these small resistances, make motion something you can feel. But space strips all of that away. It removes the clues that tell you you're moving. It removes the drag that whispers across your skin. It removes the turbulence that hints when something changes direction or speed. In the vacuum of space, motion is not only quiet, it is flawless. Consider what happens when you ride a bicycle down a hill. The faster you go, the louder the air becomes. Your hair lifts, your clothes flutter, your skin tingles from the friction. You feel the speed because the air resists your motion. Now, imagine that same ride in a place without air. No roar, no flutter, no pressure, just the pure sensation of forward motion, stripped of every cue your body has evolved to detect. It becomes so smooth that the very experience of speed dissolves. This is the reality astronauts encounter the moment they cross the boundary of Earth's atmosphere. The roar of the rocket fades into the background hum of equipment. Outside the spacecraft windows, planets and stars do not rush past. They drift, slow and stately, as if painted onto a canvas. Inside, everything floats, moving only when pushed by a gentle nudge. It is not that the astronauts are stationary. They are orbiting Earth at nearly 28,000 kilometers per hour. But with no air to resist them, their motion becomes uniform, unbroken, perfectly silent. The vacuum of space is far more extreme than most people imagine. Even at the altitude of the International Space Station, where there are still faint whispers of atmosphere, the air is so thin that an entire cubic meter contains fewer molecules than the air inside a single soap bubble. Farther out, beyond Earth's exosphere, the average density falls to just a handful of atoms per cubic centimeter. Compare that to the air around you right now. filled with more than 10 billion trillion molecules in each breath, and you begin to understand how profoundly empty space is. This emptiness is what makes motion unfeelable. Without molecules to strike your skin or push against you, there is no physical communication between your body and the speed at which you travel. The universe ceases to give you feedback. Motion becomes a private experience that only mathematics and instruments can measure. Yet the silence of space is not only physical, it is visual. In the vacuum, there is no scattering of light, no haze, no particles to blur or soften the edges of distant objects. On Earth, the sky's blue glow, the shimmer of heat rising from pavement, the haze of moisture in the air all create a soft, shifting veil that affects everything you see. The horizon fades, colors blend, distance becomes impressionistic. But in space, the stars are sharp. The darkness is absolute. Sunlight falls uninterrupted, unscattered, harsh and brilliant. Shadows are knife-edged. There is no atmospheric cushion to soften the world. Even the Milky Way, viewed from orbit or beyond, appears with shocking clarity, as if the universe has turned its face directly toward you. And yet, for all that clarity, there is no sensation of motion. The stars do not streak by. They move too slowly across your field of vision for the eye to detect. The background of the universe is so immense that even traveling at thousands of kilometers per hour cannot create the sense of passing through it. If you look out the window of a speeding car, the roadside whips by in a blur. But if you look at distant mountains, they barely seem to move at all. Now replace mountains with objects thousands of light years away, and the effect becomes even more pronounced. The universe stays fixed, serene, and still. This too is why space feels like silence. Scale diminishes sensation. Distance smooths motion into stillness. Even within the solar system, distances are vast beyond human intuition. The moon is over 384,000 kilometers away, yet it fits neatly into a single glance from Earth. Mars can be tens of millions of kilometers distant and still appears as a small amber point. Outer planets, even larger than Earth, shrink into dots, and beyond that, the stars themselves are separated by trillions of kilometers. When you move through such a landscape, motion becomes imperceptible. This effect is so profound that early astronauts reported feeling suspended, not flying forward, not falling, not rising, just floating in a vast, unchanging black. Some described it as peaceful, others as eerie. But all agreed. Space feels like nothing you've ever felt before. It is the ultimate stillness, not because nothing moves, but because everything moves together. Inside this stillness lies another truth. Sound, as you know it, cannot travel through space. Sound requires a medium, air, water, metal, something for vibrations to move through. In a vacuum, no such medium exists. If two astronauts were to drift inches apart in open space without radios, they could shout with all their strength and hear nothing but their own breath. Communication becomes dependent on equipment. The environment strips away the last remaining cue your body has to detect activity: vibration. Even temperature behaves strangely in space. Without air to conduct heat, objects illuminated by the sun can become blisteringly hot, while those in shadow drop to freezing. Yet there is no sensation of hot wind or cold breeze. The temperature changes occur slowly through radiation rather than convection. There is no tactile warning, no prickling, no stirring in the air. Heat and cold seep into objects without the atmospheric drama you're familiar with on Earth. All of these sensations, soundlessness, stillness, smoothness, feed into the deeper illusion that nothing is happening. Yet in reality, everything is happening. Spacecraft race along orbital paths. Planets whirl around stars. Stars themselves sweep around the galaxy. You are surrounded by motion so immense and so continuous that it becomes indistinguishable from rest. Even cosmic radiation, a steady stream of high-energy particles, passes silently through your body. Every second, tens of thousands of particles from deep space strike you, yet you feel none of them. They are too small, too fast, too subtle to register. Space interacts with you constantly in ways you cannot sense. Its silence is not emptiness, it is simply beyond the reach of your biology. Astronauts often report a paradox. Space feels deeply peaceful, yet profoundly alive. The quiet is not dead, it is vibrant. The emptiness is not lifeless, it is filled with particles, waves, fields, and motion. But all of it flows too smoothly, too gently, to disrupt the calm. The universe does not announce its presence, it hums beneath perception. Back on Earth, surrounded by air and weather and sound, you might imagine that silence means nothing is happening. But in space, silence means that everything is happening in perfect synchrony. There is no friction to cause resistance, no air to produce turbulence, no medium to give you feedback. Motion becomes the default state. Stillness becomes the illusion. And so, as you move through the galaxy, carried by Earth's rotation, Earth's orbit, the solar system's drift, and the Milky Way's long spiral, space offers no whisper, no breath, no tremble to reveal that journey. It wraps your motion in its perfect vacuum and lets you glide. This brings us to a deeper question, one that carries us onward. If space is silent because it is empty, then what happens when emptiness itself interacts with motion? When gravity and vacuum shape each other across the vast architecture of the cosmos? Part 8. How your senses evolved for a smaller world. Your inner ear can sense the start of a car or the sway of a train, but not the turning of a planet. Human perception was shaped by forests, rivers, and plains, not the sweeping arcs of celestial mechanics. So the greatest motions of your life occur quietly, beneath the threshold of your biology. To understand why the vast motions of the cosmos pass unnoticed through your life, you must begin with the simple truth that your senses were never built for them. Every sense you possess, sight, sound, touch, proprioception, balance, evolved for survival in a world measured not in millions of kilometers, but in arm's lengths and strides. Your ancestors navigated uneven terrain, judged the bend of tree branches, tracked the footsteps of prey, and found shelter against wind and rain. Their world was intimate and immediate. The Earth's rotation, its orbit, the sun's drift across the galaxy, these motions were far too slow, far too smooth, far too grand for evolution to spend energy detecting. Take the vestibular system, the delicate network of structures in your inner ear that governs your sense of balance and motion. Inside are tiny canals filled with fluid and hairs that sway when the fluid moves. These hairs detect acceleration, changes in speed or direction, not constant motion. If you spin quickly and stop, you feel dizzy because the fluid continues to swirl, sending your brain conflicting signals. But if you ride a train at a steady pace, the fluid settles, and the sensation of motion disappears. Your inner ear is designed to warn you of sudden shifts, not to report the steady gliding of a world turning beneath you. Earth's rotation is one of the most constant motions in the universe. Its speed changes only over spans of millions of years, slowed gradually by the gentle tug of the moon's tides. There is nothing abrupt in that motion, nothing your inner ear could ever detect. Even if Earth spun twice as fast, you wouldn't feel the rotation directly. You might notice stronger winds or different patterns in the weather, but the spin itself would remain silent. Your biology is tuned to variation, not constancy. Your sense of vision operates under similar limits. Sight evolved to interpret contrast, motion across short distances, and changes within your immediate environment. You can detect the flicker of a shadow, the shift of a branch, the subtle movement of an animal in tall grass. But the stars, which appear to drift across the night sky, move too slowly for your visual system to interpret as motion during a single moment. Their movement is real, caused by Earth's rotation, but it unfolds on a scale your eyes were never meant to resolve. You see a still sky, even as your planet turns beneath you at more than 1,000 miles per hour. The same is true of Earth's orbit. You move roughly 30 kilometers every second around the sun, but your eyes cannot see the background of stars sliding across the sky fast enough to reveal the motion. The stars are too distant, their light too steady. Your world appears still because your visual system evolved for the immediate, not the cosmic. It interprets stability where there is constant change. Touch tells the same story. When you walk, run, or lean into the wind, you feel pressure, because air molecules collide with your skin. In space, or in motion through space, there are almost no molecules to touch you. Even here on Earth, our atmosphere rotates with the planet, swept along by gravity and thermal gradients. Because the air moves with you, not against you, you feel no cosmic wind to reveal your motion. Touch only detects changes in the world immediately around your body. The grander movements of planets and stars are too vast, too smooth, too uniform to disturb the layer of atmosphere that brushes your skin. Proprioception, your sense of body position, also evolved for small-scale survival. It helps you place your feet on uneven ground, reach for objects without seeing them, and keep your balance as you run or climb. It interprets tiny shifts in muscle tension, joint angle, and bodily alignment. But none of these sensors can register Earth's motion through space. The rotation, orbit, and galactic drift are far too steady, shared across every cell of your body. There is no contrast for proprioception to detect, no shift, no change, no imbalance. Even sound, which guides your attention with remarkable sensitivity, fails in the face of cosmic motion. Sound travels through air, water, and solid materials as vibrations, but motion through space creates no vibrations when space is nearly empty. Earth's movement through the galaxy produces no audible hum. The vacuum absorbs nothing and transmits nothing. The silent void keeps your world quiet, masking the speed at which you move. Your senses, every one of them, operate in a narrow band that matches the environment of your evolutionary history. They are finely honed for the scale of trees, rivers, predators, and shelter. They are exquisitely sensitive to dangers and opportunities on the ground beneath your feet, but they are blind to the scale of astrophysics. They cannot detect slow, continuous changes. They cannot sense uniform motion. They cannot perceive forces that act equally on every atom in your body. This selective awareness was not a flaw, it was a necessity. Early humans had no need to detect the curvature of space-time or the drift of celestial bodies. They needed to find food, avoid predators, navigate landscapes, and care for their communities. The senses that evolved allowed them to survive in a world governed by immediate concerns. Yet there are hints, ancient, subtle, that our ancestors felt the rhythms of the cosmos indirectly. Day and night, the waxing and waning of the moon, the seasons shifting through the year. These patterns, though tied to Earth's rotation and orbit, were experienced not as motion, but as cycles. They shaped migration, agriculture, ceremony, and myth. The cosmos was written into culture long before it was written into science. Even today, your body responds to cycles more than motion. Circadian rhythms sync with light and darkness. Seasonal changes influence mood and metabolism. The gravitational pull of the moon nudges tides and subtly affects water within living organisms. These responses are to patterns, not to speed. Your biology tracks the effects of cosmic motion, not the motion itself. If your senses were adapted to feel Earth's drift through space, your life would be unrecognizable. You would stagger under the sensation of the planet's rotation. You would feel the curve of the Earth's orbit, like the continuous turning of a giant wheel. The galaxy's spiral motion would drag at your perception. Every second would feel like acceleration. Every moment would overwhelm you. Instead, the universe protects you through uniformity. Gravity holds everything to the planet. The atmosphere moves with it. The solar system glides through the galaxy with motion so steady they erase themselves from your awareness. Stillness is, in many ways, an evolutionary gift. It allows you to live on a moving world without ever feeling displaced. It grants you a sense of groundedness in a cosmos filled with vast, silent journeys. And it lets the rhythms of life, your heartbeat, your breath, your sleep, unfold peacefully, untouched by the invisible speeds that carry you. Your biology, tuned for a smaller world, gives you a stable platform from which to explore the universe with your mind instead of your body. Tools, mathematics, telescopes, and physics extend your senses outward, revealing what evolution did not prepare you to see. They show you the turning Earth, the orbiting planets, the drifting stars, and the expanding universe. They allow you to perceive the cosmos through knowledge, not sensation, And so the next time you feel stillness settling around you, remember that this stillness is not the absence of movement. It is the filtering of movement. It is your biology choosing silence over overwhelm, which leads naturally to the question at the heart of the next chapter. If your senses cannot reveal the vast motions of space, then what do the hidden motions inside your own atoms look like? And what do they whisper about the restless nature of reality itself? Part 9. The hidden motions. Inside every atom you carry. Even at the smallest scales, nothing is still. Electrons whirl in probabilistic clouds, protons are built of quarks in constant motion, and the fabric of space-time itself flickers with quantum fluctuations. You are made of restless things, held together by patterns that never stop moving. To grasp the strangeness of the world inside you, imagine shrinking yourself down, not just smaller than a grain of sand or a single cell, but smaller than an atom, smaller than the particles that make up that atom, smaller still until even the idea of size begins to lose meaning. At this scale, the calm stillness you feel in your everyday life dissolves completely. The quiet world you move through is revealed as an illusion built from unimaginable activity hidden beneath the surface of matter. Start with the electrons, those elusive, shimmering entities that shape chemistry, electricity, and the bonds that hold your molecules together. In the old picture, electrons orbited like tiny planets around a tiny sun. But quantum mechanics shattered that simplicity. Electrons are not little spheres circling in neat loops. They exist as clouds of probability, smeared across space, buzzing in and out of positions defined not by certainty, but by likelihood. They occupy orbitals, regions where they are more or less likely to be found, but they never stop moving, never settle into a quiet rest. Their presence is a vibration, a wave, a shift in the electric field that wraps around each atom. Even the most stable atom is full of motion. Hydrogen, the simplest of all, with one proton and one electron, vibrates with quantum energy that never reaches zero. Even at absolute zero, where all classical motion should freeze, the electron cannot stop moving. This is the zero-point energy of the universe, the baseline hum of existence. It is as if the universe does not permit stillness, as if motion is the default state of all things. Move inward into the nucleus, and the strangeness intensifies. Protons and neutrons are not solid beads. They are composite objects built of quarks, tiny point-like particles bound together by the strong nuclear force, the most powerful force known. But even bound is a misleading word. The quarks inside a proton do not sit quietly. They churn, they flicker, they exchange gluons, the carriers of the strong force, in a chaos so intense that physicists describe it as a sea of particles continually appearing and vanishing. A proton seems stable on the outside, but internally it is a storm. The mass you attribute to a proton, the mass that makes your body solid, that lets you feel the ground beneath your feet, does not come primarily from the quarks themselves. It comes from the energy of their motion, the swirling dance of the strong force. Einstein showed that energy and mass are interchangeable, and at the quantum scale, this truth becomes astonishingly literal. You are made not of static pieces, but of energy trapped in patterns. Zoom out slightly, just enough to see atoms forming molecules, and the motion reveals itself again in the bonds that hold matter together. Chemical bonds are not threads or hooks. They are the result of electrons occupying shared regions of space, creating stable configurations that minimize energy. The molecules of your DNA, your proteins, your blood, your bones, all of them exist because of motion. Electrons flowing through orbitals, nucleons vibrating in nuclei, fields interacting at distances measured in trillionths of a meter. Even the atoms in your body are not fixed in place. Inside every cell, enzymes twist and fold, ions rush across membranes, water molecules collide billions of times per second in a liquid dance that sustains life. Heat itself is motion, atoms vibrating faster or slower depending on temperature. When you feel warm, you are feeling the restless jittering of molecules. When you feel cold, you are feeling that jitter slow, but never stop. Absolute stillness is unreachable. Beneath all of this lies an even stranger truth. The vacuum of space, the empty region between particles, is not empty at all. Quantum fields permeate everything, and even in perfect vacuum, they fluctuate. Particles flicker into existence and vanish, borrowing energy from the fabric of space-time for the briefest possible moments allowed by the uncertainty principle. This quiet, omnipresent trembling is everywhere, inside atoms, inside you, inside the universe itself. Stillness, at the deepest level, simply does not exist. This restlessness is not chaotic, it is structured. Electrons do not move randomly, they follow the mathematical shapes of orbitals. Quarks are confined, as if tied by invisible springs, unable to escape the particles they form. Quantum fluctuations obey strict rules laid down by the fields that generate them. The motion is profound, but it is not wild. It is ordered, lawful, harmonious, and it is ancient. Every atom in your body carries a history billions of years old. The hydrogen atoms in your cells were formed in the first minutes after the Big Bang. The carbon, nitrogen, oxygen, and iron in your blood and bones were forged in the hearts of stars. Those stars lived, burned, collapsed, and exploded. Their ashes drifted through space, forming new clouds that eventually condensed into the sun, the planets, and ultimately you. Every atom inside you has been moving for billions of years, through cosmic cycles far larger than life itself. The motion of those atoms did not stop when they became part of a cell or a bone or a strand of hair. Their quantum vibrations continued, their orbitals continued to shift, their nuclei continued to churn. Even as you sit still, even as you fall asleep, your atoms carry their restless histories forward. This microscopic motion shapes everything you experience. Your thoughts, your emotions, your memories, all arise from electrical signals in the brain, tiny pulses created by ions flowing in and out of neurons. Your heartbeat exists because waves of charge ripple across cardiac muscle cells. Every breath carries oxygen atoms into your bloodstream, where they bind and unbind with hemoglobin in a dance of quantum probabilities. Life is not static. Life is motion, expressed in billions of interacting particles. Even the solidity you feel when you touch a surface is the result of motion. The atoms in your hand never truly contact the atoms in a table. Instead, the electric fields around those atoms repel each other. That repulsion, the interaction of moving electrons, creates the sensation of touch. You feel solidity because atoms refuse to merge, because motion at the quantum level enforces boundaries. Your entire experience of the world emerges from this hidden world of motion. Yet your senses, shaped for a larger, slower scale, cannot perceive any of it. You feel still even though trillions of particles inside you move with relentless energy. You feel solid even though matter is mostly empty space, structured by fields and motion. You feel continuous even though every atom in your body is replaced over the course of years. Stillness is an illusion born from motion too small to see. But this illusion is not a deception. It is a comfort. It allows you to live in a world whose true nature, vibrating, fluctuating, restless, would be overwhelming if experienced directly. Biology filters the universe into something survivable, something gentle, something you can inhabit without constant awareness of the quantum storm beneath your skin. And yet, knowing that storm exists changes your sense of yourself. It reveals that your stillness is not the absence of motion, but the harmony of countless motions working together. You are not a solid object. You are a process, a pattern, a dance of particles shaped by forces and fields, which naturally leads us to the next question. If every atom inside you is restless and every process in your body is built from motion, then how does gravity gather all of this motion into the stable form you call your physical self? And how does it bind you to the earth as it falls through space? Part 10. How gravity turns motion into orbit. Orbit is not a path, but a balance, falling towards something while moving fast enough to never reach it. The earth falls around the sun, the moon falls around the earth, and you, held to the planet by gravity, fall with it. What feels like stability is in fact a slow, unending descent. To understand this balance, imagine standing at the edge of a tall mountain, one so high that its summit brushes the upper layers of the atmosphere. If you were to throw a stone gently, it would arc downward and hit the ground a short distance away. Throw it harder, and it travels farther before falling. Throw it harder still, and the arc lengthens, bending gradually with Earth's curvature. But there is a special speed, a precise, delicate velocity at which the stone never reaches the ground at all. Instead, as it falls, the Earth curves away beneath it at exactly the same rate. The fall becomes endless. The stone enters orbit. This idea, first imagined by Isaac Newton, is the essence of orbit. It is not hovering. It is not suspension. It is not a cosmic magic trick that keeps objects aloft. It is falling, pure, continuous falling, perfectly matched by sideways motion. Earth itself obeys this law. Our planet travels around the sun at roughly 30 kilometers per second. At that speed, the sun's gravity pulls Earth inward, bending its path into a closed loop rather than a straight line. Without that inward pull, Earth would fly off into space along a straight trajectory. Without the sideways motion, Earth would plunge directly into the sun. Gravity and motion work together to create the balance that keeps our world warm, lit, and alive. From your perspective on Earth's surface, this global fall feels like stability. But that's only because every part of the planet, including you, shares the same descent. You fall with the ground beneath your feet. You fall with the air you breathe, the oceans that surround you, the continent you stand upon. There is no relative difference for your senses to detect, no shifting of forces that would reveal the journey you are on. The moon's orbit works the same way. It falls around Earth, completing one full loop every 27.3 days. Gravity pulls it inward constantly, yet its sideways motion keeps it skimming past the planet's surface. In the early days of humanity, even before mathematics or physics, people sensed this relationship. They saw the moon glide across the sky at a steady pace, never drifting away, never falling down. They imagined invisible strings or divine hands guiding it. The truth, revealed millennia later, is simpler and more elegant. Gravity bends the moon's motion into a circle. But just like Earth's orbit, the moon's path is not a perfect circle. It is an elongated ellipse, shaped by gravitational nudges from the sun and the other planets. Sometimes the moon is closer to Earth, sometimes farther. Yet its dance remains graceful, unbroken for billions of years. The moon is a falling companion, locked in motion, quiet in its descent. Extend this idea outward and the pattern becomes astonishing. The planets fall around the sun falls around the center of the Milky Way. The Milky Way falls toward the Virgo cluster. The Virgo cluster falls through the cosmic web toward the Great Attractor, a region of immense gravitational influence, hundreds of millions of light years away. Gravity shapes motion at every scale, sculpting paths not through forceful pushes, but through gentle, continuous curvature. And this curvature points us toward one of the great revolutions of physics, Einstein's reinterpretation of gravity. In Newton's world, gravity is a force acting across space, pulling masses toward each other. But Einstein showed that gravity is something deeper, a warping of space and time. Objects moving through this warped geometry follow the straightest possible paths, which appear to us as curves. Orbit, then, is simply an object following the natural path through curved space-time. No push, no pull, just motion flowing through geometry. Imagine a marble rolling across the surface of a stretched rubber sheet. If the sheet is flat, the marble travels straight. But place a heavy ball in the center of the sheet, and the marble curves around the depression. To an outside observer, it looks as if the marble is being pulled toward the center, but the marble itself feels no force. It is simply following the shape of the surface. The sun creates a similar depression in the fabric of space-time. Earth moves through this curvature, tracing the smooth loop we call its orbit. And because the curvature is steady, continuous, and ancient, Earth's fall becomes imperceptible. You are held to Earth's surface by gravity, pulled toward the center of the planet with a force that defines your weight. But even this familiar feeling is not the sensation of gravity. It is the sensation of resistance. The ground pushes back against gravity's pull, creating the pressure you interpret as weight. If the ground disappeared beneath you, if you stepped into a vacuum where nothing supported you, you would feel weightless, not because gravity is gone, but because nothing resists it. This is why astronauts float in orbit. They are not free of gravity. The pull of Earth at the altitude of the International Space Station is still about 90% as strong as it is on the ground. They float because they are falling endlessly around Earth, never hitting the surface because their forward speed keeps them forever in motion. Their weightlessness is the sensation of unresisted fall. This same sensation can be briefly felt on Earth. In a rapidly descending elevator, your stomach lifts as your body experiences a momentary drop. On a roller coaster, you feel suspended at the top of a loop. In these moments, your body approximates free fall. But the sensation never lasts. The ground always rises. The tracks always catch you. The elevator always slows. Support returns, and with it comes the familiar push of weight. In orbit, the support never arrives. The fall never stops. This balance, this endless fall, this quiet geometry is what makes the solar system stable. It keeps planets in place for billions of years. It ensures that Earth receives a constant flow of sunlight, not bursts or droughts. It allows moons to shape tides, comets to glide through elongated paths, and spacecraft to navigate the void with precision. Even chaos within the solar system, asteroids tugged by Jupiter, the slight wobble of planetary orbits, the long-term drift of resonances, occurs within the broader, calming architecture of gravity's balance. Everything falls, but everything falls in patterns. And you are part of that pattern. Your body, made of restless atoms, rests upon a planet that never rests. You are falling through space even as you sit still. You are descending around the sun even as you sleep. You are part of an orbit that existed long before you were born and will continue long after you are gone. This slow, unending fall creates the illusion of stability. But it also creates something else, something deeper, more beautiful. It creates continuity. It creates rhythm. It creates the cosmic heartbeat that defines the cycle of days, seasons, and years. And it raises a natural question. If the entire solar system moves through space in this balanced fall, then what larger motion carries the sun and all its planets across the great currents of the galaxy? Part 11. The Cosmic River. Carrying the solar system. The sun pulls the planets, but the galaxy pulls the sun. Our entire solar system drifts through the Milky Way in a long, spiraling arc carried by the mass of 100 billion stars. That drift shapes the sky you see, the seasons you feel, and the future of our place in the cosmos. To imagine this motion, picture the solar system as a tiny boat, small, luminous, and fragile, floating along a vast invisible current. The sun, with all its planets and moons, is not fixed in space. It does not stand still. Instead, it moves through the Milky Way as though carried by a colossal river of stars and dark matter. This river has no water, no waves, no shorelines. It is a river of gravity, flowing through space-time itself. This journey begins with the sun's orbit around the center of the Milky Way. Our galaxy is a spiral, its arms stretching outward like glowing trails of stardust. Inside one of those arms sits the sun, drifting at an astonishing speed of about 220 kilometers per second, or roughly 500,000 miles per hour. At that speed, the solar system takes about 230 million years to complete a single orbit of the galaxy. Since Earth formed, our planet has completed only about 20 such galactic years. Humanity has existed for a tiny fraction of even one. Yet you do not feel this motion. You feel no galactic wind, no swirl of stars passing by, no tug as the sun curves through its orbit. The entire solar system, sun, planets, moons, comets, asteroids, dust, all of it moves together as a single coherent structure. Because everything shares the same drift, there is no difference for your senses to register. You are as much a passenger of the galaxy as you are a passenger of Earth. But the galactic motion is far from simple. The sun's path is not a flat circle. It oscillates, bobbing gently above and below the galactic plane. Imagine the sun moving in a slow, wave-like pattern, crossing the midline of the galaxy every few tens of millions of years. This vertical motion is caused by the gravitational pull of the Milky Way's disk, which contains stars, gas clouds, dust, and an enormous amount of dark matter. Like a pebble caught in a deep bowl, the sun moves up and down, always drawn back toward the center. This rhythm may subtly influence life on Earth. Some theories suggest that as the sun passes through denser regions of the galaxy, comet activity in the outer solar system could increase, sending icy bodies inward. Others propose that cosmic radiation might rise slightly during certain galactic phases, affecting Earth's atmosphere in delicate long-term ways. Though these effects remain speculative, they highlight a profound truth. Earth's environment is shaped not only by the sun, but by the galaxy's vast gravitational currents. The solar system also drifts relative to nearby stars. Our closest neighbor, Proxima Centauri, lies about 424 light-years away, seemingly close on galactic scales, yet unimaginably far for human travel. As the sun moves through the galaxy, it passes through regions of varying star density. Sometimes the solar system moves through relatively empty space. Other times, it drifts near clusters or ancient streams of stars left behind by past galactic mergers. These stellar encounters can reshape the outer boundaries of the solar system. Far beyond the planets lies the Oort cloud, a spherical shell of icy bodies stretching nearly halfway to the next star. As the sun moves through the galaxy, the gravitational pull of passing stars or giant molecular clouds can disturb these distant objects, sending some of them inward as long-period comets. When a comet appears in our sky, bright and trailing a luminous tail, it is often the result of a nudge given millions of years earlier by the sun's journey through the Milky Way. This cosmic river does not flow through a calm, orderly universe. Our galaxy is part of a larger structure, the local group, a collection of more than 50 galaxies bound together by gravity. The Milky Way itself moves toward the Andromeda Galaxy, which approaches us at about 110 kilometers per second. In roughly 4 billion years, the two galaxies will merge, their stars swirling into a giant elliptical galaxy. The solar system, still drifting along its path, will be carried into this new cosmic architecture. Earth will likely still orbit the sun then, though the night sky will be dramatically transformed. Even the local group is not stationary. It falls toward a massive region of space known as the Virgo cluster. And beyond this lies an even greater gravitational influence, the Great Attractor, a mysterious region about 150 million light-years away that draws galaxies toward it. All of these motions, local, galactic, and intergalactic, layer together into one enormous drift. Yet all of this movement remains hidden from your senses. Why? Because motion by itself is silent. It requires resistance or acceleration to be felt, and the galaxy offers neither. The sun moves smoothly along its orbit. The planets move smoothly around the sun. The solar system moves smoothly through the Milky Way's gravitational landscape. There are no sudden shifts, no cosmic turbulence, no collisions of atmosphere or drag. The vacuum of space ensures that motion remains pure. The cosmic river is tranquil not because it is slow, but because it is unobstructed. Even the stars around us move with incredible speed. But because space is so vast, their relative positions change only slowly over thousands of years. The constellations you see today are nearly identical to the constellations ancient civilizations saw. Yet beneath that apparent stability lies constant motion. The stars drift. They approach and recede. They orbit the galactic center along their own paths. The sky is a slow dance of lights. Astronomers can track these motions using a technique called proper motion. Over decades, precise measurements reveal stars sliding slightly across the sky. Barnard's star, one of our nearest neighbors, moves noticeably over human lifetimes, but the shifts are too subtle for the unaided eye. Again, your senses evolved for a smaller world. Inside the solar system, the sun's motion through the galaxy shapes the environment in another profound way, through the heliosphere. This vast bubble of charged particles and magnetic fields generated by the sun's solar wind protects the planets from much of the cosmic radiation flowing through the galaxy. As the solar system moves, the heliosphere changes shape, compressed when moving into denser regions of interstellar gas, expanded when the surrounding space is emptier. For billions of years, this protective bubble has shielded Earth, modulating the radiation environment in which life evolved. Even light from distant galaxies bears the imprint of our motion, the cosmic microwave background, the faint afterglow of the Big Bang, appears slightly warmer in the direction the solar system is moving and slightly cooler in the opposite direction. This shift, called the dipole anisotropy, tells us that our galaxy is moving at about 600 kilometers per second relative to the early universe. Every second, even as you breathe quietly on Earth, you are carried through space by vast currents stretching back to the dawn of time. And yet, your life unfolds gently because all of this motion is shared. You drift with the solar system drifts with the galaxy drifts with the local group. There is no friction, no wind, no physical sensation to reveal your journey. This is the cosmic river, a cascade of motion too smooth and immense to ever disturb you. But as silent as these motions are, they shape everything: the night sky, the distribution of stars, the history of life, and the universe's long-term future. The sun's path through the Milky Way may influence comet strikes. Our galaxy's motion may guide its fate in a future merger. Even the structure of the cosmos, the cosmic web of dark matter and galaxies, determines how these rivers flow. So, as you sit here now feeling weightless in your stillness, you are being carried along a path older than Earth, older than the sun, older than almost anything you can imagine. You are drifting through a galaxy whose spiral arms turn slower than glaciers, but with a grace that shapes the universe itself. And this leads us to the next quiet question in our journey. If the solar system moves through the galaxy with such smooth precision, then why does the galaxy itself feel so still? And what deeper motions lie beneath the Milky Way's serene spiral? Part 12. Why you don't feel the galaxy moving through space. The Milky Way doesn't simply exist, it travels. It moves through the cosmic web, guided by gravity from distant clusters. But because every star, every planet, every molecule in your body shares the same smooth velocity, the motion disappears into a deeper stillness. You move with everything, and everything moves with you. To understand why you feel none of it, imagine for a moment that the galaxy were a ship, immense, ancient, and silent. The sun is only a single lantern hanging from the deck. Earth is a grain of dust drifting in its glow. But the ship itself sails on a sea so vast that even the idea of waves begins to lose meaning. And because you are inside the ship, woven into its timbers, made of the same atoms that form its hull, you feel nothing of its passage. There is no sway, no tilt, no tremble, only the illusion of stillness. This illusion begins with uniform motion. Your senses evolve to detect change, acceleration, deceleration, sudden shifts in direction. But the Milky Way does not accelerate sharply. It does not lurch. It does not twist abruptly. Its motion is steady across millions of years, smooth across distances so large they overwhelm imagination. The galaxy moves through space like a glacier made of starlight, sliding through the dark without resistance. The numbers describing this motion are breathtaking. Relative to the cosmic microwave background, the faint ancient glow left over from the Big Bang, the Milky Way moves at about 600 kilometers per second. That's more than 1,000,000 miles per hour. Yet even at that staggering speed, nothing in your body stirs. There is no sound, because sound cannot travel through the vacuum of space. There is no wind, because the galaxy does not sweep through an atmosphere. There is no friction, because intergalactic space is too empty to offer resistance. There is only motion, pure, uninterrupted, and unnoticed. Every star in the galaxy shares this journey. The sun is not an independent traveler. It is bound to the Milky Way by gravity, just as Earth is bound to the sun. The planets, moons, comets, and asteroids follow the sun as it follows the galaxy, all moving in concert with the same enormous drift. Because every particle of your body, every atom, every quark, every electron is part of this collective motion, you cannot feel it. Your senses detect differences, not absolutes. And here, there are none. You are carried effortlessly like a leaf in a gentle current. But what is the galaxy moving toward, and what moves it? The Milky Way is part of a small neighborhood of galaxies known as the Local Group. This collection includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of dwarf galaxies orbiting them. The entire Local Group glides together through the cosmic web, an immense network of filaments made of dark matter, gas, and distant galaxies. These filaments form the scaffolding of the universe, guiding the motion of galaxy clusters like rivers guide the flow of water. Gravity is the architect of this motion. It reaches across millions of light years, pulling galaxies toward regions of higher density. One of these regions is the Virgo cluster, a massive aggregation of thousands of galaxies located about 50 million light-years away. The Local Group is falling toward Virgo at hundreds of kilometers per second. But even the Virgo cluster is not the final destination. Beyond it lies a far more mysterious structure. The Great Attractor, a gravitational anomaly so massive that it draws entire galaxy clusters toward it. The Great Attractor sits near the center of the Laniakea supercluster, a grand, sprawling continent of galaxies. The Milky Way is one of the rivers in this gravitational landscape. It flows along invisible slopes of spacetime, drawn toward deeper basins of mass. But because these flows unfold across distances larger than any star can cross in a lifetime, the motion appears frozen to your senses. Your world, confined to a small patch of the galaxy, cannot perceive the shifting of the cosmic web. This is why the night sky looks stable. The constellations appear eternal, their shapes unchanged across millennia. But this stability is an illusion born from the immense distances between stars. They move, each with its own speed, direction, and orbit. But their motion is too slow relative to human lifetimes to be noticeable. You live inside a vast ballet that moves with exquisite grace, each step taking tens of thousands of years. This trick of perception extends to the galaxy itself. Spiral arms appear fixed, stars seem anchored in place, but the spiral pattern is not made of the same stars over time. It is a density wave, a moving compression that stars pass through like cars passing through a temporary traffic jam. The stars orbit the galactic center, but the spiral pattern rotates at a different speed. You are moving through the arm even as the arm moves through the galaxy. Stillness, at this scale, is simply motion too grand to witness. If you could step outside the galaxy and watch it from afar, you would see the Milky Way rotating, drifting, pulled by the gravity of distant clusters. You would see stars circling the center like sparks in slow motion. You would see the galactic disk wobble slightly, like a spinning plate gently flexing. You would see the halo of dark matter extending 6 times larger than the visible galaxy, shaping everything you observe without ever revealing itself directly. Dark matter is the quiet conductor of this cosmic motion. It does not emit or absorb light, but its gravity sculpts the galaxy's rotation. Without dark matter, the spiral arms would unravel. Stars at the edges would fly outward, but instead, the galaxy holds together, wrapped in an invisible halo. This halo forms the basin in which the Milky Way floats. It defines the path the galaxy takes through the cosmos. Yet, because dark matter interacts weakly with ordinary matter, it leaves no trace for your senses to find. Inside the solar system, the galaxy's motion influences subtle details of life. Cosmic rays, high-energy particles from distant supernovae, arrive at Earth with a distribution shaped by the galaxy's drift. The shape of the heliosphere, the bubble carved out by the sun's magnetic field, changes as the solar system moves through different interstellar environments. These influences are gentle, unfolding slowly over eons, and your senses are shielded from them by Earth's atmosphere and magnetic field. Even time itself, carries the imprint of the galaxy's motion. Einstein revealed that motion affects the flow of time. Clocks moving quickly tick slightly slower compared to stationary clocks. But because every clock in the solar system shares the galaxy's speed, the effect becomes relative only when comparing different frames of reference. Your perception of time, your heartbeat, your breath, your dreams remains untouched. So why does the galaxy feel so still? Because you are part of its motion. You are embedded within it. You move with it as naturally as you breathe. Motion without resistance is indistinguishable from rest. When everything in your environment shares the same velocity, motion dissolves into stillness. This is the cosmic paradox you live inside. You are always moving, yet you feel at rest. You are part of a galaxy drifting through space, yet the galaxy feels motionless. Stillness is not the absence of motion. It is the perfection of motion. And this quiet perfection leads us to our next question. If the galaxy moves so smoothly that you cannot feel it, then what deeper currents shape the universe itself, and what hidden motion carries all of existence forward through time? Part 13. How time itself emerges. From motion, time isn't a separate thing that flows around you. It is woven from motion, rotation, orbit, vibration. If every particle in the universe stopped moving, time would stop with it. But nothing stops. Nothing has ever been still. And so time continues, carried forward by motion at every scale. To understand this idea, imagine peeling away everything you normally associate with time. Clocks ticking, days passing, seasons shifting. All of those markers are built from motion. A clock ticks because gears turn. A digital display counts because electrons flow. The Earth has days because it rotates. It has years because it completes a long, elegant orbit around the sun. Time in your life is nothing more than change arranged with rhythm. But beneath these familiar motions lies something deeper. Motion isn't just how we measure time. Motion is what creates time. In the equations of physics, time is not an external river carrying events from past to future. It is a dimension woven directly into the structure of space-time, given meaning only through the motion and interaction of matter and energy. If you could remove all motion, freeze every vibration inside every atom, halt every rotation of every planet, stop the expansion of the universe, then nothing would change. No event would follow any other. There would be no before or after. Time would lose its arrow and flatten into something meaningless. But the universe does not permit such stillness. At every level, motion is constant. It is the heartbeat of reality. Start with the simplest motions, vibrations inside atoms. An atom is not static. Its electrons shift within orbitals. Its nucleus trembles with energy. Every particle inside it flickers according to quantum rules. These vibrations define energy levels. They define how atoms interact, absorb light, emit light, bond to form molecules. The very concept of a second can be defined by the vibration of a cesium atom. 9,631 oscillations of its electrons mark the passage of 1 second. In this sense, time is the rhythm of the microscopic world. Zoom out to the human scale, and motion defines your experience of living. Your heartbeat has a rhythm that your body uses to regulate itself. Your breath creates cycles. The rise and fall of your chest, the flow of air in your lungs, these motions tether your awareness to a flow of moments. Your brain measures time through chemical changes and electrical pulses, motion at levels too small to feel yet essential to thought itself. Without motion in neurons, there would be no memory, no prediction, no sense of continuity. Consciousness depends on motion threading through the brain. On the scale of Earth, time takes on a grander rhythm. The rotation of the planet creates night and day. The orbit around the sun creates seasons. These motions carve time into shapes that life has learned to follow, year after year. Plants bloom, animals migrate, oceans circulate, all in sync with the turning of the planet. Even human culture, agriculture, tradition, storytelling, celebration, evolved around these cycles. Time is the measure of Earth's motion. Beyond Earth lies the deeper clock of the solar system. The planets orbit at different speeds. Their motions create alignments, eclipses, long-term cycles that ancient civilizations tracked with remarkable precision. Even without knowing physics, early people sensed that time and motion were inseparable. The sky was a clock, and the heavens were gears. But even this is only the beginning. Time emerges from motion not just in the solar system, but in the galaxy and the universe at large. Our galaxy rotates. Every star, billions of them, follows an orbit shaped by gravity and dark matter. The Sun completes a galactic year roughly every 230 million Earth years. With each orbit, the position of the solar system shifts. Cosmic environments change slowly, subtly. Clouds of dust drift, fields of radiation shift. Entire star clusters move along rivers of gravity. These motions unfold across spans so immense that human lifetimes barely scratch their surface. Yet these motions help define the long-term evolution of the galaxy. They are the slow ticking of a cosmic clock. And beyond the galaxy lies the expansion of the universe. Space itself stretches. Galaxies drift apart not through motion in space, but because space expands between them. This expansion defines the largest scale of time imaginable. The rate of expansion, the Hubble rate, acts as a kind of cosmic tempo, telling us how old the universe is and how quickly its structure evolves. Even here, time is measured through motion, the motion of galaxies receding from one another through the stretching of spacetime. Einstein revealed that time and motion are linked even more intimately. According to relativity, time does not flow at the same rate everywhere. Motion slows time. Gravity slows time. A clock on a fast-moving spacecraft ticks more slowly than a clock on Earth. A clock at sea level ticks more slowly than a clock high atop a mountain where gravity is slightly weaker. These are not theoretical predictions. They are measured facts. GPS satellites must adjust their clocks to account for time dilation caused by both their speed and their altitude. Without these corrections, the system would fail in minutes. What does this mean for you? It means that your personal experience of time depends on your motion through the universe. Every moment you live is shaped by where you are and how you move. You age at a slightly different rate at the equator compared to the poles, because Earth's rotation causes time to flow just a bit differently. When you take an airplane flight, time passes a tiny fraction of a second differently than for someone who stays on the ground. Yet these effects are so small that you never notice them. They fold seamlessly into your life, unnoticed, but essential to the structure of physics. Time is not universal, it is personal. It is tied to your motion through space and through gravity. Even the arrow of time, the reason the past feels fixed and the future feels open, emerges from motion. On the smallest scales, the laws of physics are symmetrical. But as particles interact, as energy flows, as entropy increases, motion creates direction. Heat spreads, stars burn their fuel, galaxies evolve, motion drives change, and change defines time. If everything stopped moving, if every vibration ceased, every orbit froze, every wave flattened, the arrow of time would vanish. Entropy would no longer increase, events would no longer unfold, the universe would be frozen not in space, but in time itself. But stillness is impossible. Quantum mechanics forbids it. Zero-point energy ensures that motion persists even at absolute zero. The universe is built from fields that vibrate. Particles are excitations of those fields, motion made tangible. Space-time itself ripples with gravitational waves, tiny shivers caused by massive objects orbiting or colliding. Nothing rests. Nothing has ever rested. Even black holes, often described as perfectly still, radiate slowly through quantum effects. Stillness is not a state the universe allows, so the river of time flows on, not because there is a river, but because everything moves. You drift through time as naturally as you drift through space. You feel the passage of time not because it is imposed upon you, but because your body and mind are made of processes, rhythms, and cycles. In this way, time is not outside you. It is inside you. It is a consequence of what you are. This understanding leads gently to the next question, one as quiet as it is profound. If time emerges from motion, then what deeper motions shape the future of the universe itself? And how will these motions carry everything toward what comes next? Part 14. The faint. Tremors that reveal. Earth's motion pendulums slowly twist. Stars drift by fractions of a degree. Clocks tick differently on satellites. These gentle signals are the only clues that Earth is moving through the void. They are small, quiet, almost invisible, but they confirm what your senses cannot feel. If you relied on your senses alone, you would conclude that Earth is perfectly still. The ground does not pull or sway beneath you. The air is still. The horizon appears unmoving. But the universe leaves subtle fingerprints, small, delicate tremors that reveal the truth beneath the calm. These traces are faint enough that you will never feel them directly, yet persistent enough that physics can detect them with exquisite precision. One of the earliest and most elegant clues comes from the Foucault pendulum, a simple device invented in 1851 by French physicist Léon Foucault. It is nothing more than a massive weight suspended from a long cable, allowed to swing freely in any direction. When set in motion, the pendulum swings back and forth in the same plane. But over time, that plane appears to rotate. If the pendulum is placed at the North Pole, it makes a full rotation every 24 hours. At the equator, the rotation vanishes. Everywhere else, the rate falls somewhere in between. This rotation is not caused by the pendulum itself. It is caused by Earth turning beneath it. The pendulum reveals what your senses cannot detect, the slow, steady rotation of the planet. The twist is silent, gentle, measured in degrees per hour. But it is irrefutable. It shows that the floor beneath your feet is moving, even though it feels perfectly still. Another quiet tremor comes from the stars themselves. Night after night, the constellations appear to rise in the east and set in the west. But this motion is not truly theirs. It is Earth's rotation. Over months, those same stars drift slowly along the sky, shifting with the seasons. Over centuries, their positions change entirely. Ancient star maps do not match the modern sky. Even the pole star changes. Polaris has not always been the North Star, and it will not remain so forever. These drifts occur because Earth's axis wobbles like a spinning top. This wobble, called axial precession, takes about 26,000 years to complete a full cycle. It is invisible in a lifetime, but unmistakable across millennia. The wobble changes which stars mark the seasons, which stars guide navigators, which stars anchor the northern sky. It is a cosmic whisper from Earth's ongoing motion. Yet the stars reveal even subtler motions when viewed with precision instruments. Over decades, they shift by mere fractions of a degree. These shifts come from Earth's orbit, the sun's motion around the galaxy, and the galaxy's own journey through space. On human timescales, the stars appear fixed, but on astronomical timescales, they drift like slow-moving embers carried on a vast cosmic wind. Then there are the clocks, our most precise windows into the universe's hidden motion. Atomic clocks are so accurate that they would lose less than a second over the age of the universe. When these clocks are placed in different environments, in airplanes, satellites, mountaintops, or deep underground, they tick at slightly different speeds. This is not a flaw. It is a consequence of relativity. According to Einstein, time flows differently depending on motion and gravity. A clock moving quickly through space ticks more slowly than a clock at rest. A clock closer to a massive object ticks more slowly than one farther away. The satellites in orbit around Earth experience both effects. They are farther from the planet's gravity, which speeds up their clocks slightly, and they move quickly, which slows them down slightly. The net result is a predictable difference. Engineers must adjust satellite clocks by microseconds per day to keep GPS accurate. Without these adjustments, your navigation system would fail catastrophically. These tiny differences are proof of Earth's motion, proof that time itself responds to the planet's speed and position. They are faint tremors, quiet distortions in the rhythm of time, caused by the Earth's unending journey. The most dramatic clues, however, come from the subtle shifts in the frequency of light itself. When Earth moves toward a star, the star's light is slightly compressed, shifting toward the blue end of the spectrum. When Earth moves away, the light is stretched, shifting toward red. This effect, known as Doppler shift, is the same phenomenon that causes a siren to change pitch as it passes by. Astronomers measure this shift with extraordinary precision, allowing them to detect Earth's orbital motion, its rotation, and even the Sun's movement through the galaxy. Every year, Earth moves toward certain stars and away from others, and their light wobbles in response. These shifts are minuscule, a fraction of a percent, but measurable. They are another whisper of motion carried across trillions of kilometers. Perhaps the faintest tremors of all come from gravitational waves, the ripples in space-time predicted by Einstein and finally detected in 2015. These waves are generated by massive objects spiraling together, such as colliding black holes or merging neutron stars. When a gravitational wave passes through Earth, it stretches and compresses space by less than the width of a proton. Instruments called interferometers can detect these tiny distortions using beams of laser light. When a wave passes, the length of the instrument's arms changes ever so slightly, revealing a tremor not from Earth's motion, but from the motion of distant cosmic giants. These waves tell us that space-time itself is dynamic, rippling with the echoes of ancient collisions. They are the faintest tremors imaginable, yet they confirm that the universe is never still. Even Earth's own shape reveals its motion. The planet bulges slightly at the equator because of its rotation. This bulge affects the path of satellites, the pull of gravity, and the shape of the oceans. Earth is not a perfect sphere. It is subtly flattened by its spin. This is a quiet fingerprint of motion hidden beneath the surface, but measurable through physics. Tides provide another clue. The ocean rises and falls because the moon pulls on Earth's water. But the timing and height of tides reveal more than lunar gravity. They reveal Earth's rotation. The tides lag slightly behind the moon's position, creating a drag that slows Earth's rotation over millions of years. Fossil corals show that ancient Earth had shorter days. Hundreds of millions of years ago, a day lasted around 22 hours. The planet's rotation is slowing because of the tides, and the lengthening of the day is a soft, imperceptible tremor in the life of Earth. Even the atmosphere carries evidence of motion. It spirals with the planet, shaped by Coriolis forces that twist winds and storms. Hurricanes rotate clockwise in the southern hemisphere and counterclockwise in the northern hemisphere. This rotation comes from Earth's spin, a grand, invisible control that shapes weather, climate, and the patterns of the oceans. All of these clues, pendulums twisting, stars drifting, clocks ticking differently, tides shifting, storms spiraling, come together to reveal a world in motion. None of them are loud. None of them disturb your senses. They are whispers in the background, detectable only through careful observation and patient measurement. And this quiet truth highlights a profound idea. Motion does not need to be felt to be real. The universe is filled with motion so gentle, so perfectly shared, that it slips beneath the threshold of human awareness. But science gives us tools to listen to these faint tremors. Through them, we glimpse the true nature of our world. And as we follow these clues deeper into the mystery, we arrive at the final question in this journey. If these faint signals are the only signs of Earth's motion, then what do the largest motions of all, the motions of the cosmos itself, tell us about where the universe is going? Part 15. The comfort of knowing you are never truly still. Stillness can feel fragile. Motion can seem overwhelming. But together they form the balance that makes life possible. You are carried safely through space by forces older than the Earth itself. And in that long, silent journey, you are part of the universe's most ancient rhythm. To feel still is to feel safe. It is to sense the ground beneath your feet and trust that it will not shift. It is to breathe into a quiet moment, wrapped in a calm that seems absolute. Yet this stillness, this deep, steady presence, is not born from the absence of motion. It is born from motion so smooth, so ancient, so perfectly shared that you are sheltered within it. The Earth beneath you spins. The planet falls around the sun. The solar system glides through the galaxy, and the galaxy itself, drifts through the cosmic web, and you move with all of it without ever needing to brace yourself against the journey. This gentle truth can feel paradoxical. You are never still, but you are never unsafe. From the moment you are born, you are cradled in a motion that sustains you. The Earth's rotation sets the cycle of day and night, shaping sleep and wakefulness. Its orbit defines the seasons, guiding the growth of plants and the rhythms of ecosystems. The sun's drift around the galaxy protects the solar system with its magnetic field, sheltering you from cosmic radiation. Even the galaxy's motion through space is part of a gravitational architecture that allowed stars, planets, and life to form. You are not separate from these motions. You are woven into them as surely as any leaf is part of a tree, any wave part of an ocean. And yet, your body grants you the gift of stillness. It filters out the cosmic scale. Your senses show you only what is relevant to survival: changes in wind, the shift of light, the ground beneath your feet. The Earth's motion is too constant to notice, too smooth to detect, too vast to matter to your biology. You do not feel the spin of the planet because nothing disturbs the motion. You do not sense the orbit of Earth because you fall with it. You do not perceive the galaxy drifting because every part of your body shares the same immense velocity. This is not a limitation. It is a protection. Evolution designed your senses for the scale of human life, for land, sky, water, and motion measured in heartbeats, not in millions of miles. If you could feel every cosmic current, every shift in space-time, every vibration inside every atom, your world would be overwhelming. Stillness is nature's way of letting you live comfortably amid grandeur. But knowing the truth does something powerful. It replaces fear with wonder. It reveals that the universe is not chaotic or violent beneath its surface. It is profoundly ordered. Every motion that carries you is part of an intricate geometry. Gravity shaping orbits, space-time guiding paths, galaxies forming clusters, clusters forming filaments. You move not through chaos, but through design. The forces that cradle you have existed since the dawn of time. Gravity has curved space-time since the first stars ignited. The Earth has orbited the Sun for more than 4 billion years, carrying countless forms of life through cycles of stability. The galaxy has spun through darkness since long before the solar system was born. Everything that holds you now held your ancestors, and their ancestors before them, stretching back through deep time. And in turn, you carry forward that lineage of motion. Every breath you take is part of a rhythm that echoes the rhythm of the cosmos. Every heartbeat is timed within a world that spins with ancient precision. Every night you lie down to sleep, you participate in the great drift through space, a drift older than mountains, oceans, or the continents themselves. This perspective can offer a unique kind of comfort. You're never adrift. You're always held by gravity, by the Earth, by the harmony of the solar system and the quiet structure of the galaxy. The motions that surround you are not threats. They are the reason you can live at all. Consider gravity, the force that holds you to the Earth. It feels personal, grounding you gently. But it is also cosmic. It binds galaxies, guides stars, shapes the vast architecture of the universe. The same law that keeps your feet on the ground keeps planets in orbit and galaxies from flying apart. You are connected to everything by the same fundamental force. In gravity's embrace, you belong to the universe in a literal, physical way. And then, consider inertia, the guardian of your sense of stillness. It keeps you moving with the Earth, smoothing every transition so that motion becomes invisible. Inertia protects you from feeling overwhelmed by the Earth's spin and orbit. It allows you to sleep soundly while you are carried through space at unimaginable speeds. Without inertia, you would feel every shift of the planet, every curve of the orbit, every drift of the galaxy. But with it, you feel calm. Even the Earth's rotation, which could have been chaotic or erratic, is steady and ancient. Its spin slows only slightly over millions of years. Its orbit remains stable. The sun's path through the galaxy is smooth and predictable. These motions, unchanged across generations, create a cosmic cradle for life. Far from feeling small in this vastness, many find reassurance in it. You are not alone in your motion. Every person you have ever known is carried by the same currents. Every creature, every tree, every mountain shares your quiet journey. Even stars, planets, and galaxies participate in the same cosmic drift. You are embedded in something immense, something older and grander than human imagination, yet gentle enough that you can sit here, breathing softly, feeling the illusion of stillness. This is the comfort of knowing you are never truly still. You belong to a universe that moves with grace. It holds you in its rhythm. It carries you without asking for your effort. It surrounds you with harmony at every scale, from the atoms in your cells to the great spirals of galaxies. To know this is to feel connected, to feel safe, to feel part of something eternal. And as this journey settles into its final moments, one last question arises, not to pull you forward, but to rest quietly in your thoughts. If all motion in the universe is so gentle, so ancient, and so perfectly shared, then what does it mean to live your life in the center of this quiet, cosmic flow?